Did you know that people die from depression? Every 40 seconds, someone somewhere in the world take their own lives. 90% of them suffer from a brain disorder, mostly depression. We might think that this is weak and selfish of them, and that brain disorder sufferers should be grateful for living in the right time and not some 50 years ago when there was nothing to be done for them. Yet, our treatments for brain disorders are far from good. You cycle through medications as long as it takes to find the right one. You deal with innumerable side effects. You emerge and relapse and emerge and finally realize that you have to be on medication forever. So they are not weak or selfish. We failed to fix what makes them think they don't deserve to live. And this is largely because for so long, we underestimated the complexity of our brains. What does this mean? The brain is composed of 100 billion neurons, cells that transmit information at 100 trillion connection spots called synapses, enabling us to be. Fascinating, right? What's more fascinating is that this is only 10% of the brain. 90% of the brain is composed of glia, non-neuronal cells that since the 19th century were taken out of context, considered as lifeless glue holding neurons together. But times changed, and only in the last 20 years, scientists identified subtypes of glia and assigned essential functions to each. They discovered that a subtype of glia, astrocytes, have bidirectional communications with neurons at synapses. They even found the imprint of astrocyte dysfunction in many brain disorders, including depression. Now, we just need to decode the language of astrocyte neuron communication to understand how the brain truly works, so that further down the road, we can realize how things go wrong in brain disorders. One study in this regard is my thesis. I hypothesized that a specific receptor, a protein on the astrocyte that acts as a post box, capturing the message coming to the cell, is necessary for astrocyte neuron communication. So I took away this specific receptor from the astrocytes of the mouse's brain and watched these astrocytes and their neurons deal with it. I saw that the activity of these astrocytes and their nearby neurons is significantly lower compared to normal astrocytes and their nearby neurons. So I proved that the absence of this specific receptor causes interruptions in the communications at the synapse, and I decoded a small part of astrocyte neural language. Now, this is not the immediate cure to brain disorders, but I believe progress towards understanding brain disorders will not happen if we underestimate the surreal complexity of our brains. Thank you.